this video we discuss about chemical reaction of amino acid. So if you look at the general structure of amino acid, okay, there are two different functional groups. The first one is from amine. So you should know, right, amine actually is base properties. And then this one is carboxylic acid. Carboxylic acid is acidic properties. So meaning that amino acid can react with acid and can react with base. So let's check one by one. So the first reaction is amino acid react with hydrochloric acid. When it react with hydrochloric acid, meaning that HCl will react with the amine part. Okay, the rest just remain the same. So hydrogen, carbon, ethane, and then carboxylic acid just copy. And then when amine react with HCl, it will form ammonium chloride. So NH3 positive, Cl negative. Next, since amine can react with HCl, at the same time, amine can react with sodium hydroxide, which react with the carboxylic acid part. So, meaning that this part we just copy, and then the carboxylic acid part will become COO negative Na part, which we learned in carboxylic acid. So, H2O is the byproduct. Okay, next, react with alcohol in the presence of acid catalyst. So meaning this is the reaction between alcohol and carboxylic acid. Okay, we are using concentrated H2SO4 here. So this reaction is esterification. At the same time, okay, base can react with this aliphatic alcohol, which is a weak acid. So the reaction will happen for the amine part, means it will form the ammonium chloride again, and then this one, esterification. So C double bond O and then OCH3 here. So always remember, when acid react with amino acid, so it will react with the base part. At the same time, since this one is alcohol, right, it will react with carboxylic acid to form ester. Next, the fourth reaction is the reaction with nitrous acid. So the reagent is sodium nitrate with hydrochloric acid, and then the temperature is 0 to 5 degrees Celsius. Okay, over here this is nitrous acid, right? So it will form a diazonium salt ion at the amine part, and then it will form the carbonate ion. From the carbonate ion, right, it can react with water to form alcohol, and then it will react with the chlorine part to form halogen, like halogen over here, and then from carbon-carbon double bond as well, elimination reaction happen. So this is the product form when react with nitrous acid. At the same time, nitrogen gas will produce as well. So total there are 4 products when amino acid react with nitrous acid, which is sodium nitrate plus HCl at 0 to 5 degrees Celsius. Okay, another important point for amino acid is amino acid can undergo an internal acid-base reaction in which a proton is transferred from the carboxyl over here and then become carboxylate, and then amino group NH2 to form dipolar ion here, ammonia. Okay, and initial NH2 now become NH3 plus. So we call it Zitron ion. This is special properties for amino acid. So what is Zitron ion? We define as a molecule with an overall charge of 0, because positive negative equal to 0, which has a positive charge on one atom here and a negative charge on another atom here in the same molecule. So this we call as Zitron ion. Next, about peptide bond. Dipeptides are formed when two amino acid, two amino acid react with one another. So the reaction involves elimination of water to form a peptide bond, the C double bond O and H. So it's a peptide bond, or another name we call it as amide bond. This reaction is called as a condensation reaction. Okay, and then normally, right, polypeptide are amino acid polymer with contain up to 50 amino acid residue. For example, protein. Generally, are amino acid polymer which are made of more than 50 amino acids. And one more information we always have to remember, the N-terminal with free of NH2 always written on the left-hand side, okay, left-hand side, and the C-terminal with free of carboxylic acid at the right-hand side, okay. So the formation of the peptide bond is eliminate OH from the carboxylic acid and the H from the amine. Next, you look at one sample question. Serine and alanine are example of alpha amino acid. So if you look at this compound, right? So this is alanine with the short form ALA, and then this is serine, given the short form is SER. So question number 1, give the IUPAC name of serine. So you have to check. There are two functional groups. One is carboxylic acid, and then over here is amine, and then here is alcohol. So what is the name for serine? After that, draw the structure of serine each in a strong acidic and basic medium, meaning that this will form the zitron ion. And then question number 3, draw the structure of all possible dipeptide when serine is reacted with alanine, meaning that I can react between ALA with SER or SER with ALA. So there are two possibilities. So now let's check the answer. Answer 1, give the IUPAC name. So based on this, we have to always remember position number 1 is the carbon with carboxylic acid, because carboxylic acid will give the priority first. So this is C1, C2, C3. So the parent's name is propanoic acid. At the position 2, there is amine group. So the name is 2-aminopropanoic acid. Always remember number and alphabetical must with dash. So this is the IUPAC name for ALA. And then for SER, again 1, 2, 3. There are 3 carbon as well. So the parent's name is propanoic acid. At the position 2, there is amino. And then position number 3, there is OH group, means hydroxyl. So 2-amino-3-H hydroxypropanoic acid. Okay, question number 2, draw the structure of serine in each a strongly acidic medium, means it will react with the amine part. Then it will form the NH3 positive. The rest just copy. And then serine in strongly basic medium means the carboxylic acid will react with the base, so it forms COO negative. So the other part over here, just copy. Okay, for question number 3, draw the structure of all possible dipeptide when serine is reacted with alanine. So there are two possibilities, can be ALA react with serine or serine react with ALA. And then always remember, okay, amine at the left-hand side, carboxylic at the right-hand side. So the reaction is between, okay, the elimination of OH from the carboxylic acid group and the, okay, this actually is one hydrogen. So I will eliminate one hydrogen, so hydrogen over here. So eliminate one hydrogen. So it will form the C double bond O and H bond. So others you just copy. So the CH3 and H2H just copy. CH2OH, COH, serine. This all just copy. Everything just copy. Okay, and then this is the formation of the peptide bond. At the same time, you can form the SER-ALA. SER-ALA is eliminate, okay, here I have draw the H over here, and then this is the 1H. So eliminate of the H2O over here. Okay, and then form, okay, NH2 remain, okay, CH2OH, H remain, and then COH remain, hydrogen remain, and then the CH3 remain. So here is the formation of the peptide bond. Must label as peptide bond. So this is SER-ALA. So when you draw the structure of all possible dipeptide, always remember amine at the left-hand side, carboxylic at the right-hand side. Same for the second structure as well. Amine at the left-hand side, carboxylic acid at the right-hand side, and then eliminate the H2O and then form the C double bond O and H. So this is the amide bond or peptide bond. Terima kasih menonton. Jangan lupa tekan subscribe, like and share. Jumpa lagi kat video seterusnya. Bye!